Hi guys, today we're going to look at how to graph these piecewise functions. So I'm looking at example 3 in your notes from the other day, and what you're going to do is you're going to look at the two functions that were given. So first I'm looking at f of x equals x minus 3 and f of x equals 2x, and I'm going to start with the one that has a domain. If you remember from the other day, the domain is the x values that are listed on the right hand side. I'm going to start with the domain that has the equal sign. And I'm going to make little mini tables. I'm going to go x is greater than or equal to 1. So 1, 2, 3, 4. Those are x values that are greater than or equal to 1. And I'm going to plug them into the function, which is in blue, right next to it, y equals 2x. So I just do this mentally. Y equals 2x. I'm going to plug in 1. 2 times 1 is 2. And then 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And then I'm going to plot them on the graph, starting with 1, 2, 2, 4, 3, 6, 4, 8. And this is saying, I'm expecting this to be a linear function. Y equals 2x is linear. And it's saying that only for x values greater than or equal to 1. So I'm only going to go to the right of 1. So you have to look at this, even though it looks like it's going up, you have to think of it as going left and right for x values greater than or equal to 1. So from 1 and on, I graph this line y equals 2x. So what's really happening is, you can imagine that like this would have been, if I continue this whole thing with the yellow would have been the line y equals 2x. It has a y-intercept of 0, it has a slope of 2, but we're like chopping it off. And we're only graphing the part that is from x values 1 and higher. So we're only graphing starting at this point here, 1, 2, and on. And then we're graphing another piece of another function, which I'm circling right now in green, when x is less than 1. So I'm going to make another little mini table, and I'm going to go, even though it says less than 1, I am going to put a 1, and then I'm going to go less, 0, -1, -2. And the reason is that the 1, even though it's not included as a domain value, I'm going to put an open circle on it. So that's why I'm circling it. So I'm going to plug those numbers into, and I just go a couple numbers back. Like you can go to -3. I just stop at like a random point. And then, because then it'll get an arrow. And then I plug into the function y equals x minus 3. So y equals x minus 3 is also a linear function. So I'm plugging these x values into that function. So I'm going 1 minus 3 is -2. That's going to be the open circle. 0 minus 3 is -3, -1 minus 3 is -4, -2 minus 3 is -5, -3 minus 3 is -6. So I have 1, -2, which I'm doing in green, with an open circle. Then -1, 0, -3, -1, -4, -2, -5, and so on. You could see the pattern, and then this is going to get an arrow to the left, because this function y equals x minus 3 is only for domain values less than 1. So from 1 on your x-axis to the left. Okay. Again, if you imagine this whole thing, like if you were to graph the line y equals x minus 3 in yellow, it would be a line that continues on in both directions with a slope of 1 and a y-intercept of -3. But we're being restricted to the domain x less than 1. So that's why we're not including that yellow part. Oh, yeah. And we're only graphing the green part, which shows x values less than 1. So sometimes the graphs will be connected and sometimes they won't. Like here, they're not connected to each other. All right, and then that's it. You don't have to label the parts. You can just leave it like that. So we'll do another one, example 4. I'm going to start by doing a table for the inequality. It doesn't really matter which one, but I'm going to do the inequality that has the equal sign. So I'm going to go a little table. I'm going to go -2. It says less than or equal to. So -2, -3, -4, -5. And I'm going to plug them into the function y equals 2x plus 8. And I'm expecting that to be linear. That's y equals mx plus b. So I plug them in. I'm going to get -4 plus 8 is 4. And then I'll have -6 plus 8 is 2. -8 plus 8 is 0. -10 plus 8 is -2. And I'm expecting a line. So -2, 1, 2, 3, 4. negative 3, 2, negative 4, 0, negative 5, negative 2. Okay, so we have x values less, so we're going to the left, arrow to the left, and stop at that point. Okay, and then the next one is y equals x squared. I'll do that one in green. X value is greater than negative 2. So even though it's not equal to, I'm going to put the negative 2, but I'm going to put an open circle on that point. So let's see, greater than. So we'll have negative 1, 0, 1, 2. This time I'm plugging into y equals x squared, and that is a parabola. That's a quadratic. So I'm expecting part of a parabola. I'm going to plug them into y equals x squared. So this is going to give me positive 4, positive 1, 0, 1, and 4. So when I go negative 2, 4, 1, 2, 1, 2, 3, 4, this lands on top of that blue circle. So when you have an open circle inside of a colored circle, you're actually not going to see the open circle. So it's going to look colored in, even though it's an open circle on top. And then negative 1, 1 is here, 0, 0 is here, 1, 1 is here, 2, 4, 1, 2, 3, 4. And the x values keep getting greater than negative 2. So I'm going to put an arrow going to the right to show that this keeps going. But I do not continue the parabola on the left side because my limit on my domain is negative 2. So I'll put it in green. This should be my leftmost point of my parabola, but then it keeps going to the right in forever. Okay. We'll do another one. Let's do example 3. So here you've got 3 functions you're graphing. It really doesn't matter which one you start with. I'm going to start with, I guess I'll start with the one with the equal sign. That's usually what I go for first. So this is telling me when x is greater than or equal to 1. So 1, 2, 3, 4, etc. And my function is just y equals 2. Y equals 2, if you remember, is a horizontal line. It's a special line. It's horizontal. So it's telling me that no matter what the x value is, my y value is always 2, 2, 2, 2. So at 1, 2 is where it starts, and then it keeps going horizontally, 2, 2, 3, 2, 4, 2, 5, 2, and x values keep getting larger. So this is going to look like that. It's going to be a horizontal line, but I'm not doing the whole horizontal line. I'm just doing it from x values 1 and on to the right. Next, I'll do the next part in red. I'm doing this domain. This one, I have a very restricted domain where it's telling me only x values negative 2 to 1. So equal sign on the negative 2. So negative 2 all the way to 1. Negative 1, 0, 1. But the 1 doesn't have an equal sign. So this is going to get an open circle. And I'm going to plug those into the function y equals x squared minus 2. That's a quadratic. So I'm expecting part of a parabola. So when I do x squared minus 2 for negative 2, I'm going to get 2 because it's positive 4 minus 2. Then it'll be positive 1 minus 2 is negative 1. Then 0 minus 2 is negative 2. And then my open circle will be 1 squared minus 2, which is going to be negative 1. So graphing those, I have negative 2, 2. Negative 2, 2. Oops. Okay. Negative 2, 2. Negative 1, 1, 0, negative 2, oh sorry, negative 1, negative 1, 0, negative 2, and then my open circle goes on 1, negative 1, which is here, open circle. So I have this little piece of a parabola that just doesn't have any arrows. It ends on these 2 endpoints, one being a colored in circle, one being an open circle. And then I have one more function, which I'll do in green, for a domain of x is less than negative 2. So I'll do that over here. You have x and y. X values are less than negative 2. Notice there's no equal sign, but I'm going to put the negative 2 with an open circle, and I'm going to go less, negative 3, negative 4, negative 5. And I'm going to plug those into the function y equals negative 2x minus 4. And that is linear, so I'm expecting a line. So when I plug in, I'm going to get 0 here, and then I'll have 6 minus 4 is 2. And then 8 minus 4 is 4, and then 10 minus 4 is 6. So this is going to be a little piece of a line. So negative 2, 0 will be here, but this is going to be open circle. So I have to go back and fix that. Negative 2, 0 there. And then negative 3, 2. Negative 4, 4. Negative 5, 6. And these x values keep getting less. So I'm going to put an arrow to the left. This is going to keep going to the left. All right, so these are like, very detailed. You have to just pay close attention to your details. You're going to do a couple of these for practice tonight, and I'll go over them in class today. Okay, thanks.